This is a laboratory which has been set up to demonstrate time constant in conjunction with a small transistor to activate a lamp and give a time delay at turn on. We're using the Rigol oscilloscope with the roll function, and we're able to demonstrate the rise or the charging time of the capacitor, and then in conjunction with the circuit which has been built up with a BC549, couple of resistors, 1000 microfarad capacitor and the lamp. Let's have a closer look at that circuit. Here it is here, the BC549 really working at its extreme maximums at this point, but the BC549 was at hand, and in a short demonstration, even though its maximum limits are being exceeded, it's not a really big deal here. 1.5k resistor to limit the base current. Be careful, don't make that resistor too large. If the base current is too small, the transistor won't turn it on as a switch, and there'll still be voltage dropped across the emitter collector, and then you'll really exceed the specification. The Zener diode here is used to step the voltage to the base up. Normally this turns on, of course, at 0.6 volts. But with the capacitor charging and charging up to the rail voltage of 14 volts, I don't want this transistor turning on at like 0.6 of a volt in the charge cycle. So here's the charge cycle of the capacitor. I don't want the transistor turning on right down the bottom. I want the transistor turning on more up here after one time constant. So that Zener diode 8.2 volts just ensures that I've got 8.2 plus the 0.6, I've got around about 9 volts with that capacitor charging, and it's to reach 9 volts before the transistor turns on and then makes the light bulb light up. The whole lot is accomplished with a piece of wire across this capacitor. And of course, when the capacitor is short-circuited, the transistor is off and the light is off. When the wire is opened, the capacitor can charge via the 1.2k resistor, and at the 10 volt mark, or around about there, the transistor turns on, and we draw collector current, and the lamp illuminates. Let's have a look how that works then in practice. Using the roll function on the oscilloscope, I've got a run-stop control over here, and I've got channel 1 set for DC, and I've got the 0 point down at the bottom of the graticule. 2 volts per division, 2, 4, 6, 8, 10, 12 volts, and then the circuit's currently on, the lamp is illuminated. If I get my piece of wire, which is the switch, I can short out the capacitor and open it up again. And I'll do that, and we'll see it on the oscilloscope, shorting it out, opening it. And when it opens, we've got the charging taking place here. And we need 10 volts, that's going to be about here, before that lamp illuminates. So I'll hold the camera back a little bit, and I'll short circuit that capacitor, and okay, go. Here's the charging taking place. Note where the light just turned on. I'll do that again. Short-circuited, open. And we're on. As soon as we get up to that 10 volt mark, we reach the threshold of the Zener, and then we start drawing current through this base part of the circuit, turning on the transistor, which then makes the light illuminate. So basically this is a turn-on delay circuit that we have here. Quite a handy thing to know about, and a good fundamental use of the capacitor in conjunction with a small transistor and a Zener diode and a lamp.